All right, so this task is pages 5 through 10 in your packet, and it's on permutations and combinations. I may have to do it in 2 parts depending upon how long it takes. This is a task that typically, if you were in class, you would be working on your own without any teacher assistance, and it would teach you combinations and permutations. But there are obviously some places where people struggle, and I wanted to kind of go through the task to kind of show you what you need. Obviously, you need to be reading it all. And then you're going to use this to complete pages 11 through 13 over the course of the next 2 days. So with permutations and combinations, what we're talking about first is the fundamental counting principle, okay? And y'all, that's just how many options do you have? So this talks about a deli has a lunch special, which consists of a sandwich, soup, and a dessert for $4.99. They offer the following choices. So for a sandwich, you can get a chicken salad sandwich, a turkey sandwich, a ham sandwich, or a roast beef sandwich, okay? So those are your picks. Then for soup, you can get tomato, chicken noodle, or broccoli cheddar. And then for dessert, you get cookie or pie. And if you pick one of each of those, then you pay $4.99, you get your meal. So it says, use the diagram to determine the number of different lunch combinations. Now, I don't think that diagrams are actually really that beneficial because sometimes they get crazy and it takes up too much space and there's not really any reason. So going back to the fundamental counting principle from Algebra 1, all this talks about is basically your number of possibilities. So what you're going to do every time is you're going to look at how many sandwich choices do you have. You have chicken, salad, turkey, ham, or roast beef. So you have 4 sandwich choices times you have how many soup choices. You should have 3 soup choices, tomato, chicken noodle, or broccoli cheddar, times your number of dessert choices, which is cookie or pie, or 2. So at that point, you should get 24 possibilities, y'all, and that's your answer. That's it. Okay, so total number you have for each thing, and you're going to multiply them together. Okay, so B says, Carl has 5 shirts, 3 pairs of pants, and 2 sweaters in his closet. How many different outfits consist of a shirt, a pair of pants, and a sweater? Y'all, it's just like picking an entree, a side, or a meat, okay, or whatever we're doing. So he has 5 shirts times 3 pairs of pants times 2 sweaters, y'all, and he gets 30 outfits. Same idea, okay? So rolling a dice and tossing a coin, same thing. When you roll a dice, how many sides does a die have? 6. So you have 6 possibilities. And then you toss a coin, and remember, coins only have heads or tails, so you only have 2. So you end up with 12, okay? So that would be, we would just say 12 different outcomes. All right, now license plates are letter, 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 number, number, number. Think about the license plate on your car. It's made up of letters and numbers. So how many different license plates can be created? Well, you have to know that for letters, there are 26 letters in the alphabet. So for the first license plate, you get 26 choices, or for the first letter. Then for the second letter, you have 26 choices again. Then for the third letter, you have 26 choices again. Now for numbers, y'all, remember you can have 0 through 9, so that's 10 choices. So number is 10 times 10 times 10. So when you're done, you should have 17,576,000 possible license plates. Y'all, that sounds like a lot, but it's really not. If you think about every household has 2 or 3 cars in the state of Georgia, think about that. So padlock, 4-digit combination using digits 0 through 9. How many different padlock combinations are there? Y'all, digits 0 through 9. That's 10 numbers. Count on your fingers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 10 numbers, and it's a 4-digit combination. So it's going to be 10 times 10 times 10 times 10. Okay? And so when you're done with that, that's going to be 10,000 combinations. Okay, so that's all the fundamental counting principle. Now we're moving into permutations and combinations, okay? So definition, a permutation is an ordered arrangement of objects. The order of the object matters. This is the biggest thing of the day. Permutations, the order matters. A different order creates a different outcome. So there are 8 people running a race. How many different outcomes are there for the race? Y'all, this is a permutation because think about the Olympics. If you, let's say I'm running in the Olympics and I come in first and I win the gold medal, but then the next time the Stuhler runs and she comes in and with first and wins the gold medal, those are 2 completely different outcomes. So what we have to think about here is to come in first place, if you have 8 people running the race, to come in first place, you have 8 choices of people, okay, that can get first place. But what happens at second place? Do you have 8 people to pick from again? No, because somebody already got first place. So if you have all the teachers on this hallway, okay, let's say Miss Stuhler comes in first. That was of our 8 choices. Now she can't come in second. So now we're going to have 7 people to choose from. And then for third place, you're going to have 6 people to choose from. And then from there, it's going to go all the way down to 8th place, where you have 1 person to choose from. So there are 40,320 possible outcomes for this race. Okay? What this is, this whole long written thing, is really called a factorial. And you'll notice the thing down here. It says the example above requires you to multiply a series of descending numbers. This can be written as 8 factorial. So this is the same thing as 8 exclamation point or 8 factorial. Okay, so you'll see some examples. 9 factorial would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so now if you want 6 factorial, you would do 6 times 5 times 4 times 3 times 2 times 1. Okay, now this is also in the calculator, so you don't have to type it out. So like if I wanted 14 factorial, I don't want to have to write out 14 times 13 times 12 times 11. Okay, so you can also do your calculator, okay, where you actually press the math button and then you go all the way over to probability, and look, it's option 4 down there. Okay, so if I want 8 factorial like we did, I would say 8 and then math, arrow to probability, option 4, and check this out. 8 factorial is 40,320, and I did not have to type in 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so super helpful there. All right, so now that we know what a factorial means, okay, let's revisit our race problem. So it says there are 8 people competing in the race. How many different ways can first, second, and third place medal be rewarded? Okay, how many different ways? And all we care about are first, second, and third place. Well, let's think about that. You have 8 people competing. So for first place, you have 8 people to choose from. For second place, you have 7 people to choose from. And for third place, you have 6 people to choose from. Does it care about 4th, 5th, 6th, 7th, and 8th place? No. So we're just going to do those first 3, and you're going to have 336 ways. Okay? Now, you also want to notice here that factorials cancel. Like what this is saying is if you want to use the factorial notation described above, we would do 8 factorial. However, we know that we want to stop multiplying after 6, so we divide through. Now, the long and the short of this is you need to realize, like if you have 10 factorial divided by 3 factorial, that things cancel. You can actually write this out as 10 times 9 times 8 times 7 times 6 times 5 times 4. Gotta move. Times 3 times 2 times 1. And on the bottom, 3 factorial is 3 times 2 times 1. And what you'll notice is that guess what? The 3 times 2 times 1 cancels. So you could just do 10 times 9 times 8 times 7 times 6 times 5 times 4. Okay? So if you did that in your calculator, you would do 10 times 9 times 8 times 7 times 6 times 5 times 4, which is a little annoying. Okay, and you would get 604,800. Okay, so 604,800. Now you could type it in your calculator as 10 factorial over 3 factorial. So you could do 10 math, 10 factorial over 3. Factorial, okay? The problem here is sometimes your calculator is going to overload, okay? And I promise you on your test, you're going to have something like this and on your practice. So like if I had 102 factorial divided by 99 factorial, if you try to do that in the calculator, it's going to give you an error. So like if you do, okay, so if I wanted to do, what did I say, 102 factorial. So if I wanted to do 102 factorial, okay, divided by 99 factorial, look what's going to happen. Calculating exceeds range of values. So it's not going to work. You're not going to be able to do that in your calculator. So what you're going to have to know is 102 factorial is 102 times 101 times 100 times 99 times 98 all the way down. Well, on the bottom, 99 factorial is 99 times 98 times 97 times all the way down. And what do you notice? Everything 99 and below should cancel. So our answer should be 102 times 101 times 100. And you can actually do that in your calculator. So 102 times 101 times 100. And that is something your calculator will do. Okay, so that's why you're going to have to know that rule and that cancellation. Okay, so just know that. So now we're going to get to the permutation formula, all right, where order matters. So it says in our race example, there are 8 people to choose from which we would represent n, and we're choosing 3 of them to win. Okay, so we did 8 times 7 times 6, and it totally worked. Now, there's a formula up here that you could use for permutations, but the reality is, y'all, is your calculator does it for you. Okay, so this 8p3, I want to show you how to put that in your calculator. So you would literally press 8, go to math, you're going to go over to probability just like always. This time you're going to pick option 2, which is permutation, 8p3, and it looks just like that, and you're going to get 336, so you don't have to worry about the formula. So look at C. It says 12 skiers are competing in the final round, okay, of the competition, and how many ways can 3 of these skiers finish first, second, and third? So what we're worried about here is the order matters, because remember we're finishing first, second, or third place, so we have permutation. You have 12 skiers, and you're picking 3 of them, okay? So if we're doing 12, pick 3, we're going to do 12, math, arrow over to probability, we're in a P, P3, and enter. And I'm going to get 1,320. Okay, and y'all, that's how you're going to do every permutation problem. Okay, so let's look at another example. So notice it's got your calculator directions at the top if you forget. So D says a relay race team has 4 runners who run different parts of the race. There are 16 students on your track team. How many different ways can your coach select students to compete in this race? So you have 16 people to pick from, and you're picking 4 runners. So we're going to do permutation, 16 people to pick from, and you're picking 4. So again, you're going to go to your calculator, 16, math, 16, pick 4, and enter. So you're going to get 43,680. Hopefully this is starting to make sense. Okay, so then the school yearbook has an editor-in-chief as an assistant editor-in-chief, and the staff of the yearbook has 15 students. And how many different ways can students be chosen for 2 positions? So 15 students, 2 positions. So we're going to do 15 students, 2 positions. Okay, so when we do that, 15, 2 students. So we're going to have 210 ways. Okay, so last but not least, okay, what if we talk about words? So it's important to notice that when you use the formula, repetition is not allowed. So you can't have the same person win first, second, or third place. So here, how many different ways can the letters math be arranged to create 4-letter words? Yeah, that's probability or permutation, because the order does matter. You have 4 letters to choose from, and y'all, you're creating 4-letter words, so 4P4. And if you type that in your calculator, it's 24 ways. Okay? So in the end, how many ways can the letters in classes be arranged to create 7-letter words, since the S repeats? Okay, so when we do this, we have to know this is 7 letters. So our numerator is going to be 7 factorial. Now, what we have to do is we have to divide through by the letters that repeat, because if you move the S's around, it's still going to be classes. If the 5th S goes where the 4th S is, it's still the same word. So the only letter I have repeating is S's. So I have 3 of them, so I'm going to divide by 3 factorial. And then I would just type that in my calculator, y'all, and you would get 840 words. Okay? So last one, Mississippi. There are 11 letters in Mississippi, and then there are 4 S's, so I'm going to divide by 4 factorial. There are 4 I's, and there are 2 P's. So we would type that in our calculator and we would have 34,000